This Friday is going to be the test for 4 and 5, review linear 4 and 5. And the first part of the test is going to have slope-intercept form. It's going to be 10 points. So we're going to go ahead and get started by doing these three right here. Now there's not enough room on this paper to do all the work, so I'm going to write down all the work over here. The first one we're going to be taking a look at is 3x minus 9y equals 18. We're going to solve for the y, so on top of the y you're going to put multiply and divide. Even though there's a minus sign, you don't get to add or subtract it. You either multiply or divide it. And the x is plus or minus. It's already a positive 3x, and this is already multiplying because it's to the side of the y. So what we're going to do first is subtract the 3x. That leaves me with 18 minus 3x. And now I'm going to divide by negative 9. Our final answer is y equals negative 2 plus 1/3 x. Now a lot of people feel more comfortable if the x is in the front and the b is in the back, so we can switch them out. Just remember as you switch them out to switch back the signs that come with it. So the final answer is y equals 1/3 x minus 2. So the negative sign goes with 2, becomes a minus, and the positive 3x is right there up front. So the first answer there is y equals 1/3 x minus 2. Now we're going to try the second one right there. Here we have 2x plus 4y equals to 8. Again, it's the same concept. We're solving for y, so that gets the multiply divide. And for x, we get the plus and minus. So we're going to subtract 2x first because it's already positive. And that leaves me with 8 minus 2x. And then this is multiplying because it's to the side of the y. So now we're going to divide by a positive 4. Now once that reduces, that becomes a 2 minus 1/2 x. Now again, you might want to be more comfortable putting the x first. Just take the sign with it. That becomes y equals negative 1/2 x. And that's a positive 2, so that goes a plus 2 right there. So again, for this one, we have y equals negative 1/2 x plus 2. Now for the last one, we're going to do this one right here. And again, it's the same concept. Negative 5x minus 15y equals negative 35. Again, the same concept. We're solving for y, so y gets the multiply divide. And the 5x gets the plus and minus. It's already subtracting. So we're going to add 5x to both sides. And this is already multiplying. So we're going to divide by negative 15. Once you plug this into the calculator, you end up with positive 7/3 and negative 1/3x. Again, remember, some people like the x first and the b, the y-intercept in the end, so we could flip those. Y equals negative 1/3 x plus 7/3. Okay, that's 10 points on the test. The second part has 25 points on the test, and for that one, we're going to use the calculator a lot. For question number 1, it says you're looking at y equal to x plus 3. So you turn on your calculator, go to y equal to, and put 2x plus 3. And it says I want to compare that with y equal to x. So I'm going to graph them both at the same time. Now, it'll graph the first one first and the second one second. So when I graph it, this is 2x plus 3, and this is the second one, which is 2x. Now we're looking for three different things. First thing we're going to take a look at, this is the first one, this is the second one. As you notice, the x-intercept moved to the right. And if it moves to the right, it increases. Take a look at the y-intercept. This is the first one. The y-intercept is up here, and it comes down to 0, which means it decreased. And since they are parallel, parallel means they have the same slope. And that's how we do the first one. Let's go to question number 2. How does the graph of y equal to x plus 3 and y equal to 5x minus 9 compare? Let's go ahead and do it again. In order to see how they compare to each other, I have to graph both of them. 2x plus 3, that's the first one. And the second one is 5x minus 9. Now I'm looking at three different things. I'm looking for the x-intercept, the y-intercept, and the slope. The first one is 2x plus 3. When we graph it, we'll graph first. That's the first one. and that's the second one. So first we'll start off with the x-intercept. We started off here and went to the right, which means the x-intercept increased. Here is the y-intercept, and it came down all the way down here, which means the y-intercept also decreased, just like last time. But the slope is different. I want you to think of a guy on a skateboard coming down this way. As you can tell, he'd be coming down pretty fast. But if he comes down on the second one, he comes down faster. He comes down faster because it's steeper, it's bigger. So the slope got bigger. Since the slope got bigger, we'll say the slope increased. Now we're going to do number 3. Again, number 3 is the same concept, but it looks a little bit harder because of the parentheses. But in the calculator, it makes no difference because the calculator itself will figure that out for you. X plus 3 goes right here, minus 7. Remember, that's not a negative. If it's in the middle, it's minus. If it's in the front, it's negative. So we go ahead and graph that one real quick. Again, here's the first one. Here's the second one. The x-intercept, again, moved to the right, so it increased. The y-intercept decreased. And this is parallel, which means the slopes are the same. Now we're going to try this one, but the question is a little different for this one. The question says, if we have 2 open parentheses x plus 3, and then change it becomes 2 open parentheses x plus 7, the question for this one says, does it move to the right or to the left? Alright, let's check it out. Here's the first one. Here's the second one. It moved to the left. So on top of it, it says when changes are made inside the parentheses, are they horizontal or vertical changes? If they're inside the parentheses, they're horizontal. If they're outside the parentheses, then they're vertical changes. When the slope increases outside the parentheses, is that a vertical stretch or a vertical compression? If the slope increases, well, we got to check that out by graphing. So let's go ahead and check it out real quick. We'll pop in y equals 2x plus 2x and y equals 5x. Alright, once you go ahead and graph it, there's the first one, and if you push it out, that's stretching it. See how it went up? That's stretching it. So when the slope increases, it's a vertical stretch. So if the slope decreases, it's a compression. Now we'll go to trend lines. First thing it says is predict where the next point is going to be. In order to predict where the next point is going to be, you're going to have to use a trend line. So it's kind of like you took all these points together and you create a line right in the middle of them, just like that. That's the trend line. Wherever that trend line is pointing to, that's where the next point is going to be. In this case, it's going to be 9, 15. In order to make the trend line given fit the points, how would you change the y-intercept? How would you change the slope? Alright, well, we're right here right now. To get up here, you're going to increase the y-intercept because you start off at 30, now you're at 50. So the y-intercept increases. Right now, a guy coming down here in a skateboard goes a lot faster than if the guy is over here with a skateboard, correct? So it's not steeper because it becomes slower. It's less steep, so the slope decreases. Alright, which one has a stronger correlation? The one that is straighter. The one that looks more closely like a straight line would have a stronger correlation. That one. Now here we have 2 graphs that we're going to be taking a look at, and we're going to be looking at the R value. So remember, when you start the R value, you have to turn diagnostics on. Now if you look right here, you'll see the word catalog is in blue. So you press the blue button first, then you press catalog. That will give you a list of things, of commands you could use. Well, I'm going to look for the letter D for diagnostic, and if you see right here in the green, it says the letter D. So if you just press that, we're already in the letter D's. Now we can go all the way until we find diagnostic on. You press enter, and enter one more time. See, I made a mistake. There's an X there, so you just press enter, you fix it. And try that again. Second catalog, letter D, diagnostic on, enter, enter. Alright, now we can go to stat enter. We can create that table. Now here's the numbers right here. I'm just going to create them right there. 3, 5, 7, 7, 9, 11, 13, and 16. Usually you only do a couple of points to get the slope, but we're not doing slope here. We're doing a correlation, so we need every single point. So it's 12, 13, 25, 36, 25, 18, 30, and 45. Alright, now we're going to go stat to the right for calculate. Alright, final equation for the first one is y equals 1.94x plus 8.25. The r value is 0.73. Okay, the r value is 0.73. Is it a positive correlation or no correlation? These numbers are getting bigger, 12, 13, 25, 36, 30, 45. They're getting bigger. They're getting bigger is going upward. Upwards is a positive correlation. Not negative, not no correlation. What is the equation? Y equals 1.94x plus 8.25. Which of the two has a strong correlation? Well, in order to figure this out, I got to find the r for this one. So now I'm going to go ahead and create this. So I go to my calculator and go second plus sign 712. What that does, it goes ahead and starts it up all over again. So second plus sign 712. It clears the whole thing. Stat enter. Got to fill in these numbers. 25, 26, 28, 31, 33, 34, 36. On the other side, we have 21, 10, negative 8, negative 2, 16, negative 4, and negative 15. Now, stat to the right for calculate. As you notice, we have a problem because I forgot to turn diagnostic on. So to do that, well, we can get the equation first. The equation is y equals negative 1.86x plus 59.2. As you can tell, the slope is negative, which means it's going downward. The numbers are getting smaller. The slope is positive, that's why it was positive. Now for the r value, I need to turn diagnostic on. Second catalog, the letter D, diagnostic on. Alright, now we'll go stat to the right for and a bunch of enters. It's negative 0.58. Now, which of the two has a strong correlation? In order to figure this out, you got to remember where the strong correlations are. If it's on this side or on this side, closer to the ones and negative 1, these are strong. If it's closer to the 0, these are weak. So as you can tell, negative 0.58 is kind of like 60 cents, negative 60 cents. This one right here is 73 cents. So just forget about the negative for a minute. I'd rather have 73 cents than 60. This is stronger. Which of the two has a strong correlation? This one does. Last thing, it says graph this given this graph, find the r value. So this is the same as this, but this comes in a table. This comes in the graph. So all I have to do is create a table. 4584. These are going by threes. And as you create this table, you'll be able to go ahead and just plug into your calculator. And once you plug into your calculator, you'll be able to figure out what they are. Now I'm going to approximate a little bit. So it's going to be like 50, 62, something like that. This was going to be 55, 46. This is going to be 60, 60. This is 65, 37. Again, it's approximating is fine. In this case, it's going to be 70, 50, 70, 49. And the last one is 75, 12. As you can tell, it's getting smaller, so I'd say it's going to be a negative slope. But let's find that out. Again, I go to the table. Second plus sign 712, I clear everything. Then I go ahead and turn on the diagnostic. Then I go to stat and plug in the numbers. Stat, calculate linear regression, and there we go, negative 0.86. Again, forget about the negative sign, because again, as long as it's closer to the positive one or negative one is strong. And if it's in the middle, this is weak. 89 cents is very close, 86 cents is very close to the dollar. So negative 0.86 is over here. It is very close, it's very strong. What is the R value? Negative 0.86. Again, this is a strong value. Good luck on your test tomorrow.